Hello, welcome. Today we're going to be solving the two-sum problem. That is the first problem in Leetcode and is the first problem that appears in the blind 75 Leetcode questions. My approach to solve these problems is the approach I have when I have tutoring students. I've been a math and computer science tutor for about 10 years. It has been on and off. It hasn't been constant, but I have developed a way of, this is the way I'm learning, and since I cannot be with you on one-on-one, I'm going to provide the way I approach this problem as much, as accurately as I can. So my thinking process goes this way. Since I'm preparing for any scenario, I'm not in grad school anymore. So the only possible scenario that I have to solve this problem is during an interview. Interview are high-level stressful situations. So I want to develop the ability of being very systematic for when I read a problem, either if it's a one-on-one interview, in person or through like a video call, or if it's an online assessment. Either way, I like to be systematic because the more problems I solve, I go and write down these type of things right off the bat, so I don't have to scramble all around the problem. So my approach is, first of all, I like to call it the T's, and the T's are, this is a name I just made up, okay? So the T's are the input, the type of the input, the output, and the type of the output, okay? And after I write this down like this square, I also type constraints. I make sure these three types of information pieces from my problem I can understand, and so I don't solve the wrong problem. So let's go to the exercise. The input is an array of integers, and the target is an integer. So that's very simple in this problem. So it's array integers. And we have two inputs. The target is 9, and the output is an array of integers, but we are interested in the indexes of the numbers that make the target. So I'm going to write it down. An array integers of indices. Indices. Okay? And then what are the constraints? For more complicated problems, more complex problems, there are going to be more constraints or edge cases that I have to take into account. But regardless of the level of complexity of the problem, I always want to get into the habit of checking the constraints. And here, I see that the minimum length of the input array is going to be 2, so I don't have to solve for edge cases such as having an array of an empty array or an array of length 1. So I'm going to save time and lines of code. And that's why in this paragraph it says we have exactly one solution. So our problem is going to be easier since our constraints are nothing to note here, but the length of array is 2. Okay, now let's take the example. The example array, let me denote this with yellow. Let's say that we have 2, 11, 15, 7, and the target is 9. So the first approach I'm going to work on is the brute force approach. This might not work if you are in a one-on-one situation with an interviewer, but for online assessments, all companies always ask you if you cannot come up with the most optimal solution, please come up with just a brute force solution. Your goal is just to get this working, okay? So in this problem, when we have array, we go directly into iteration mode. So I'm going to think about the most basic case of iteration, which is one pointer. So let's say that we have here into. Okay. I'm going to check 2 plus 11. That makes 12. That is not our target. Okay. So the next comparison I have is 2 and 15. That's 17. So the third comparison I have is 7. In order for me to do this iteration, know that I have a pointer and I'm comparing every single problem. So that's going to be a for loop of nums I, and this is pseudocode. I want to keep track of 2 variables, which is the number, the current number, and which is 2, and the index of current number, which is 0. For the second loop, which is gonna be nums j. Nums j is everything that is after the current pointer. So here, okay. So I'm gonna have the complement of the current current number plus numj. If the complement equals the target, then I'm gonna build my array with the index of the number of the current pointer, which is 0, and the index of this number, which is 0, 1, 2, and 3. 7 has an index of 3. And this is gonna be my return. Okay. This solution works, but there's a problem with this. The problem is that this runs in time complexity of big O of n squared. So this is not, doesn't perform too well, and this is not going to get you a lot of kudos during an interview with a in person. So we have another option. We have the option of using hash maps. And what hash maps allows you to do is to keep in memory the index and the number, so you can just do one pass of the array and we can have a solution working of big O of n. So let's see the hash. Okay, so let's write here. So let's switch back to yellow. So we got hash maps. Okay, so we have our array again, which is 2, 11, 15, and 7. The target is 9. So I'm going to have a for loop. I'm going to use this area here, for loop. And I'm going to have a hash. Okay. So in my for loop of nums, I'm going to use the complement And now instead of adding, I'm going to take the target, which is 9, minus the current number, which is num of I. So in this case, it's 9 minus 2 equals 7. And then I'm gonna ask myself, is 7 present in the hash? No. So I'm going to add in my hash the current number, which is 2 with an index of 0. That's gonna be my first entry in the hash. Okay, so we have if it's in hash. If it's in the hash, then that means I found my complement, and then I can return the array with the indices. And this is gonna be easy because the hash is going to store the number and the index. So it's gonna be returned here. If it's not in the hash map, we are going to add it, okay? So add number 2 with index 0 to the hash. Okay, so that is going to allow us, so when we go here, so we are not, we are not using the first approach. So I'm going to be here, I add it to the hash, then I go here, then I go here. So it's gonna be 9 minus 11 is gonna be a negative number, which is gonna be 2. So I add negative 2 with 0, 1, index of 1. Then we go here. It's gonna be 9 minus 15 is gonna be 6, negative 6. Eventually we reach 7. 9 minus 7 equals 2, and then 2 is present in the hash, so I return the index of 7, which is 3, and the index of 2, which is 0. And we got our solution, and this is beautiful because this runs in bigger complexity of n. If you want to have a copy of these notes, I'm saving them on a Jamboard. I'm gonna make them available in PDF so you can download them and just revisit them. I know my calligraphy is not, calligraphy is not the most beautiful one, but you know, this can help you also study without having the necessity of having a video. So now let's code our solution in Java. Alright, so we said in our best performance solution that we need a hash map, we need a for loop, we need of course to return the array with the indices. So let's start by declaring a map with 2 integer types because we are returning the, we need to store the number with is corresponding index. So we have hash map and then new hash map. All right, then for the for loop, oh sorry. Now we have to compute the complement, which is target minus nums of I, if hash map dot contains key of the complement, then we have to create a new array, return array equals new integer. So we have to initialize it with 2 elements. So we have hash map dot get yes, complement. And the index I. Let me see. Okay. And okay. If the complement is not in the hash map, then we have to add it. So we the hash map, and then we put the current number with this corresponding index. Okay, and let us see. Uh-oh. So we have an error on line 21. Well, return null. Okay. And accepted. And you see, I obviously got this wrong a couple times, but got it right 2 times. So this is a working process. So yes, if you have any questions, any feedback, please let me know in the comments below. And you can also find the whiteboard or blackboard notes in the description. Okay, until next time, keep on coding.